That tool or that process you learned about apples, 3 apples, 6 apples minus 2 apples, is only designed to help you simplify these terms so you can solve these. Do you guys know that? So then if you had the 6 apples minus 2 apples, you remember, what did that give you? 4 apples. You guys, do you realize what you did on the left was simply to simplify. Yeah, that's why you did all that homework over the break. Okay. Hopefully you don't wait till the night before. 4x equals 18. What do you got? Isn't this something you guys know how to do? Yeah, you look at this and you go, okay, I know how to do this. We've probably seen about 10 of them already, or more. You're going to divide both sides by what? By 4. So then that means that x equals 18 divided by 4. Okay, let's see. You always reduce, right. How do you factor 18? 2 times 3 times 3. That looks, does this look familiar? Yes. Yeah, I think, yeah, we did it already. It's just by coincidence. Okay, so this is 3 times 3. This is 2. So then x is going to equal the value 9 over what? 2. Okay, 9 halves. You're done. You simplified your improper fraction, and that's good enough. What about this? Same thing. What do you do on the left? You simplify. What do you get when you simplify? You get 3x minus 4x. Plus 2 is negative 4. What's 3x minus 4x? Negative x. Good. Plus 2 is negative 4. Okay, you okay with this? Yes. So what do you now do with this 2? Translate. Can I do an arrow down here instead of on top? Sure. Negative x is negative 4 now. The 2 on the right is now negative. And then you get negative x is, what's negative 4 minus 2? It's negative 6. Okay, good. Are you done? No. You didn't solve for x. You have minus x or negative x. You need x. Let's ask you this. There's a few things you can do. What does it mean to be looking at this negative x? Yes, that's negative 1 times x, okay? It is negative 1 times x. Now, how does that work? Well, how did it work when the value was 4? You divided both sides by 4. How did that work when the value was 3? You divided both sides by 3. How did that work here when the value was a negative 2? You divided both sides by negative 2. Do you see the consistency? You're going to divide both sides here by negative what? Negative 1. And then what cancels? Negative 1. And you get x being negative 6 divided by negative 1 is positive 6. You have a solution. Okay, you okay with that? Question, yes.
I got the same answer, but I did it the other way around at first, and then transcript thing, then I simplified.
Okay, could you translate the 2 first? Yes. And then simplify 3x minus 4x? Yes. Notice you got 3x minus 4x equals negative 6. And then you simplified. Yeah, it's the same thing. Okay, you guys okay with that? Yeah, there's more. You can translate this number first and then simplify. I just personally, I think it's better to always look at what you see. Look at what you see. What does that mean? I don't know. Look at what you have. Simplify it if you can. These others, you couldn't simplify. These terms are not like. 2x minus 3, it's done. All the other examples, you could not simplify. This is the first time you were able to simplify. So do that if you can. Simplify if you can. Not simplify if you can. Simplify when you have to. There's no choice. You know, it's not if you can. It's simplify when you're given a problem that needs simplification. So with that, what kind of problems do you guys think you'll see now? Harder problems. What? Problems that may require. Oops, sorry. Problems that may require additional steps in simplification. For example, maybe you had 6 times x minus 3 in parentheses, okay, is equal to 36. What do you guys do with this? Don't you simplify? Yeah. And what was the other idea we talked about last week under simplification? The idea of what? The distributive property. So you see how that works? So then what's 6 times x? 6x. 6 times that negative 3 is negative what? And that equals a 36. And now, can you combine like terms?
No.
No, now it looks like that typical problem. Right? It looks like the typical. So, in your mind, when you see that typical situation, you solve it in the way you typically solve it. Translate your 18. Do that first. You get 6x equals 36 now, plus what? Plus 18. So then 6x equals, what's 36 plus 18? Is that 54? Okay. Now what do you guys do? Divide both sides by 6. Translate 6. X equals 54 over 6. How do you guys factor 54? Right? Do you guys know what 54 factored is? Isn't it 2 times 27? Is that 54? Is it 2 times 27? And how do you write 27? 3 times 3 times 3? Yeah. How do you write 6? 2 times 3? What cancels? Oh, is it really 9? Okay, you could have done this. Where's the 9 at? Top or bottom? Is it top?
Yes.
Or you could have known that 454 divided by 6 is what? Is 9. Either way. Okay? Yes?
Why wouldn't you just divide by 6 in the beginning? Like divide 36 by 6 and then x minus 3 equals 6.
You could do that.
Do all of that.
No, well,
No, because we're gonna need it.
you could do that. You're right. You could do that. But what will happen, what if you have 35 here? Now, I'm not saying that you can't do the problem still the way you describe what this is 35. You can. But I'm trying to show you the most efficient approach. And the truth is, yeah, you could have just started by dividing by 6. But in general, you want to go about it this way to simplify. Because I'll show you really later on how do you deal with those cases when you have these fractions. And that comes next. As soon as you guys solve all these nice problems and you're okay.